Hello and welcome back. In this lecture, we are going to talk about two members of the collection framework, arraylist and linkedlist. Let's first start with the simplest and most used member, which is arraylist. Now, all the members of the collections framework are template classes. So after you write the name of the class that you want to use, you always have to specify the type or types of the things you want to store in the class. In these diamond brackets, like this, and this is the same for linked lists as well. So let's say I want to put integers in this array list. I'll call this values and I'll say equals new array list. I need to put integer here as well. So wherever I type the name of the class, I need to write the type that I want to store in it as well. I'll also press Ctrl+Shift-O to import Java-util array list here, and you can specify an initial size of your array list. But if you don't, the default size is 10. However, we won't specify the size at this moment. And it's worth mentioning that in template classes, you can't put a primitive type there. You need to use the equivalent non-primitive type, so I'll use integer and non-int. Now to add values to an array list, it's very simple. There's a method called add, so I'll say values.add. For example, let's add 20. Then I'll add another number, let's say 60. And let's have one more. For instance, 200. And you can get numbers from this list by saying values.get. So let's put a sys out here, and I'll say values.get. And to get a particular number, you have to give it the index of the value that you want to get. So here I've got 3 values, and the index will be 0, 1, and 2. And let's say I want to get the last item, it'll be at index 2. So if I run this, I'll get 200. Another common thing we can do, beside adding and getting values, is iterating through them. So if you want to iterate over all the items in your list, we can do that with a for loop. I'll say for int I equals 0, and I want I to go from 0 and increment it as long as it's not equal to the number of elements in the list. So there's 3 elements in this list, and I want I to go from 0 to 2, and I'll get the number of items in the list by just using the dot size method. So now I can iterate through these values. I'll say values.get I, and that will display my list. So here I've got all the values in my list. There is another way to iterate through the list. The same methods we use to iterate through arrays also works with lists. I can say here, for, then I'll write the type that I used in my array list. So in this case is integer. I'll give it a random name. Let's say my values. I'll put a colon and then write the name of my list here. So I can say sysout my values. And here I have again the values in my list. And there's another thing that I'm going to cover in this lecture, and that's removing items from the list. So far, you have learned how to add, get, and iterate through the values in your list. But how about removing them? Well, there is also a remove method. And you just specify the index of the item that you want to remove. So if you want to remove the first one, it will be 0, or the last one will be, in this case, values.size, -1. But the problem is you need to be careful when you remove items from an array list. Adding and removing items at the beginning or in the middle of the array list, anywhere except near the end of the list, can be very slow, and I'll explain why in a minute. And if you need to add or remove items in the beginning, you should use linked lists instead. So let's talk a bit about the difference between linked lists and array lists and how they work internally. Array lists is made out of arrays, so it manages arrays internally. If you look inside of an array list, it's just a bunch of elements set next to each other like this. So, moving back and forth and getting a specific item from the list is certainly fast. For instance, if you want to get an item at position 60, it's easy for Java to calculate the position in memory of that item and just go and get it. If you want to add items to the end of the list, it's usually fast. You can specify an initial size for your list here, but if you don't, it's going to have an initial size of 10 items. And if you add 11th item, it will create a new array of twice the size. And copy all the old items into that new array and then put in your new item. So sometimes it needs to create a new array internally and copy the items to it. And therefore, it gets a little bit slow adding or removing items at the beginning or in the middle of the list. However, adding items to the end or removing items at the end of the array list, it's usually very fast. So if you want to add an item to the beginning or the middle of the list, then you've basically got to move all the following items up one unit, and then you can add the item in. That's going to be very slow. So because you've got to shift all the items along. One step takes a long time to add or remove items anywhere, except near the end of the list. Thus, if the item is close to the end, then it can still be fast because you've only got to shift out like 5, 50, or whatever items, and that will be fast. Now let's take a look at how linked lists work internally. So linked lists look pretty similar to array lists and has the syntax rules. However, they work quite different internally. Linked lists consists of elements where each element has a reference to the previous and next element. So a linked list internally looks like this. And these arrows are the references to the next item, and they also have references to the previous elements as well. So to cross through a linked list can be slower than an array list, and to go and get that particular item at a specific position can be way slower as well, because you have to get the first item, get the link to the next item, get that item, get the link to the next item, and so on. It's way slower. However, linked lists become handy if you want to add an item to the beginning or the middle of the list, because then all you've got to do is, let's say I want to add a new item here. I just got to point this item at my new item, and point this item backwards at my new item instead of pointing it back at this one, and that's quite fast. So you normally use array lists, but if you want to add or remove an item at the beginning or in the middle of the list, anywhere other than near the end of the list, use linked lists. So I'm going to put this code on resources section if you want to practice on your own. So once you understand how these lists work internally, it's going to be really pretty simple. You will always know which kind of list to use, and it's very straightforward. So that's it for this lecture. Stay tuned for more interesting Java stuff.